Thank you for attending today's webinar, Building Dynamic Virtual Services in Minutes with Swagger and OAS. All right, today's presenters, my name is Dan Giordano. I am Product Marketing Manager on the Ready API side. Nathan Wright, although he's mislabeled here, he's also Product Marketing Manager on the Swagger Hub side. So are both API presenters today. Hopefully we'll be showing you some in-depth demos on the Swagger Hub side and the Ready API portfolio as well. Just little housekeeping notes. This class is being recorded. So if you want the recording, we will send that out in 1 or 2 days time after. And then if you have any questions during the presentation today, feel free to add them in the QA box. If anything is super pertinent to what we're doing at the time, I will stop and we can answer that while we're going through. If not, I will definitely get to them at the end of the class. Anything that goes unanswered, we'll try to answer back personally and send them out as well. And then we also have a quick exit survey near the end that if everyone would please take, that would be excellent. All right, so quick introduction to SmartBear. So who is SmartBear? SmartBear, it's a Boston-based company with 11 offices globally now that focus on creating solutions for developers, testers, and operations teams to help them instill quality throughout the entire development lifecycle. We're founded in 2009, so almost nearly a decade old, and we continue to add products to our portfolio, not only through acquisition, but also through our own innovation. We are owners of the popular open source tooling like Swagger and SOAP UI. And our newest additions are actually on the test management side with HipTest and Zephyr, which have both come in the last 6 months. And we create tooling across the entire SDLC. Most of what we'll be talking today is on this lower API side. So we'll be talking about Swagger Hub, our functional testing, our virtualization with Service V, and maybe some load testing there. But these are our API side of the house. On the top here, we have some of our UI testing tools like Test Left, Test Complete, and cross-browser testing.
I think the big thing here that I always like to point out with this slide is the reusability across these tools, right? It's like we'll talk about Swagger and generating one of these specifications. That's the foundation for what we do in Service V. It could be the foundation for our testing, for our monitoring components. It's like this reusability plays a really kind of important part in what we do here.
Exactly, and that'll be our pretty good theme throughout the entire presentation today.
Right.
All right, quick agenda as well. We'll talk a little bit about shifting left and where virtualization and mocking sits at the heart of that. Then we'll actually go through some of the differences between the two. We'll virtualize an OAS spec, and then we'll use that in our testing and our development actually live. All right, so to start us off today, APIs have this life cycle of their own. As they're maturing, as they're becoming kind of a full product feature in our software portfolio, they have their own linear and oftentimes bottleneck prone life cycle. So here we have our planning stage, we have our design, develop, test. These closely mirror kind of the traditional software delivery life cycle. Then we have kind of this extra one that gets specific attention on the API side is documentation to make that API consumable and actually usable once we're ready. And then deploy and monitoring stage as we're getting towards actually getting that value into the hands of the end user. So you can see here that this is pretty flat. It's shown in a waterfall type manner here, but it is linear, and just like the rest of software development, it's prone to bottlenecks at many points in this process. The SmartBear toolset is really trying to shorten this life cycle. So in our planning phase, we have our HipTest and Zephyr, but this is our first kind of position of doing two things at once and working in parallel. We have Swagger Hub, which will allow us to design our API, and at the same time, we can document. So that Swagger spec, that OAS spec is going to help us actually do both at one time and shorten up our life cycle. And then kind of what we're talking about today is this next portion where we can test and develop at the same time, thanks to our use of virtualization and Service V Pro. So once that spec is virtualized, we can start doing multiple things at once and really deliver in a shorter manner and get feedback quicker as well. Next, we have our deploy stage, which we work with most API gateways, like AWS, IBM, where we really just want to partner and be part of that ecosystem. And then we finish up here with monitoring. So that same kind of, again, we're going to talk about reusability, that same SOAP UI spec that you're making for test, you can then use to functionally monitor that API call once you're in production or once you're in a staging or test server environment where you really want to measure the performance of that API transaction. So here again, we're just really trying to shorten that life cycle and do things in parallel that don't need to be done in a sequential manner. And all of that really gets to us shifting left. So this is a concept that you've probably heard in your organization, maybe a VP, maybe CTO is talking about, with this concept of finding bugs earlier in the life cycle. As we go through and we find bugs in our test cycles and our monitoring cycles, actually when they're in production, they're going to cost exponentially more money. I know everyone quotes this IBM study, but in the development stage, bug is going to cost, let's say, $100. That same bug found once it's in production, once it's to the consumer, is going to be almost $1,500. So it really, really exponentiates quickly as you move through the cycle, as you get more people involved, and as you go farther from the code, all the spend more. You're going to spend more and portion, the testing portion, and start doing some of these activities much, much earlier. For instance, if we have a complex end-to-end testing solution or testing problem where we might have multiple APIs chained together to get that last piece of data, that's something we might have to wait for in weeks 3, weeks 4 of a large Scrum team to work on several APIs to get that ready. You'll see today with virtualization, we can get those things stood up on day 1, day 2 of the sprint, and then start testing a lot sooner. And here, it's a focus more on preventing bugs rather than finding bugs in the test phase. Again, in production, we're really trying to prevent bugs in the design and the development phase, and virtualization and the OAS spec certainly do wonders for us in this space. And then again, we'll talk today about how we can shift left and how these concepts help us here, beginning with definition-driven development, which is why we're all here. We all enjoy and use the OAS specification, but that code first versus definition driven first will really make a big impact when we're trying to get to market faster. Next, service virtualization, again, help us out with speed, help us out with dependencies. And then lastly, that testing, making sure we're actually getting feedback, actually verifying that API call underneath and not waiting for the whole application to get built and let our maybe manual testers or UI testers really carry the bulk of responsibility there. We want to take part in that. So with that, we'll start with the definition-driven development, and kind of Nathan's going to walk us through how the OAS specification really helps us out with that.
Yeah, absolutely. And, we talk a lot about definition-driven development. We think it plays a huge role in companies really kind of speeding up the way that they do things now. And as Dan has been mentioning, cutting down on issues and bugs. Really, the idea is that, instead of us writing code to fill a set of loose requirements that, are being given to us like from a business level, we translate that into something that's got a little more structure. And because it has that structure, we can actually use it to influence our development. We can stand up, SDKs. We can generate a lot of code off the back of one of these. We can use it for testing. It describes exactly what a request looks like, what a response looks like. So we can essentially use it to validate the API that has been built. And then, as we mentioned as well, the actual documentation piece is huge. For us to be able to tie this initial kind of plan or this initial design to our eventual kind of consumer-facing docs, it really keeps us honest, right? Exactly, yeah. So it's something we're going to be able to now plug in to all these different phases. Obviously, today we're really honing in on that mock vert piece, just because it facilitates a number of these other components, testing and consumption, even documentation. That's a really cool idea where, we have interactive docs, right? Where, we can provide our consumers with like a sandbox or a workspace for them to try out a lot of this functionality. we don't really want to have them, set up authentication tokens. We don't want to have them, go through integrating with our actual API. For us to be able to provide like a virtual space to do that, just a dummy environment that looks like our real one, acts kind of like our real one, but is probably, just a fraction of the overhead in maintaining, is really powerful. And it gives people like this really sticky feeling when they're using documentation, when they're getting in there, for them to be able to try something out, see simple success, and then be able to translate that to their actual integration is really important. And I think we see a lot of people really run with that and kind of provide that with the idea that, we onboard people sooner, we get them, this very straightforward like POC kind of stage, or this very simple, integration kind of setup. It's really going to make the rest of the experience much better. And we can do the hard work later. If we get people kind of into the tool or into the API and using it, making calls, it's really hard to walk away from that when we're already consuming that data and rendering it out or something like that. Great. So this is just a quick look at what we'll kind of be building out today. And one of the things that I think is really interesting here is sitting right in the center. We'll get to this in a second. Just a loose story that we're going to kind of talk our way through. Let's imagine that we all work at SmartBear and we have an HR department here that's looking to modernize. They need a new API to get user information and submit new users as they come and go from the company. So essentially the requirements here, and again, this is, quote unquote business level. We have a way to get data. We have a way to submit data, or post method. We've got a couple of different responses there depending on whether we're getting or posting. In the center is kind of the interesting part. These should share a 404 or a bad request response. This is obviously a very simple example and probably one of the more simple API kind of structures we could come up with. But the idea here is that we have a standardized component in this. We have that 404 that is going to be true across the entire API. We want to define that. We want to resolve any issues. We want to, get rid of any bugs, or, if we want to turn the status from an integer into a string or something like that. We want to do that at the highest level and then have that be kind of influenced from the top down. So all of the other calls, they would reference that 404, they would update. If we made a change to that, having, again, this kind of structure to something like a design is really going to help us when we try and, continue to make changes, resolve issues, catch issues as they're being pushed through. We hand this off to our testing team now, and they start saying, well, all our tests, we're expecting a string here, and you're giving us an integer. We know exactly where we need to go and make some changes to the design to kind of match, our test framework. So, Dan, is this? Do we want to jump into Swagger Hub and,
I'm
take a
stop
quick look?
here,
Yep.
flip over.
So yeah, we'll take a look just at once. We'll build out a specification very, very quickly. Do a lot of copy and pasting here. This isn't really intended to be like a Swagger Hub training. We'll build out the specification to match the rules that we just defined. We'll talk a little bit about some of the mocking that we can do within this tool. And it will kind of present some of the differences between mocking and virtualization that we'll get into a little bit later. But yeah, we'll kind of present building out this specification, and then we'll bring it into another tool in a few minutes to really stand up a virtual service. So at a very high level, Swagger Hub is a collection of open source tools. It's essentially a single platform for doing API design, documentation, development. We have, if we open any of these up, we would have an editor, we'd have documentation. Around that is essentially user management. So if we wanted to expose this to like a third party, or we wanted to invite another team to give feedback, that's really where we see Swagger Hub fit. But again, we're just going to use this as essentially a repository for a definition that we're going to bring into our virtualization tool. To get started, let's just go ahead and create a new spec. And clicked on the wrong place. We'll do this with the 2.0, and then we'll update it to a 3.0 just to show some of the functionality here. But we'll just create this from a blank template. Let's give it a creative name here. There we go.
Nice.
It's pretty good, right? All right. Make sure it's going into my organization. Actually, this one. Let's make sure that's public as well. And then this auto mock feature, we're going to talk about this in just a second, but let's go ahead and leave that on. Actually, let's leave that off and then add it in later. And we'll just create an API here. Now, what we've been given is this blank workspace, right? So now we could jump in here and we could start to build out our different paths and design and kind of define our functionality that we know we're going to need to support for this new HR kind of set of requirements. And as we kind of update and add in some new information, we'll find that we're starting to populate our documentation view on the right-hand side. So this is really nice because now as we build out this design, as we develop this kind of initial stage or this initial like implementation of the API, we can actually see, hey, what is this going to look like to that end user? Which is really important because this is who's going to be consuming them. This is really who we're building it for, right? Are the developers and the consumers that are going to be working with this API down the line. So we'll just go ahead and copy and paste a bunch of other stuff in here. Again, I don't want to make everybody sit through watching me type out an OAS spec. There's a couple of things that I will want to point out, though, when we do bring this in here. One is going to be, just let that load. One big one is going to be in the responses. So we can see here that, we fleshed out this GET request. We dropped in some example information, some of the, query parameters that we support here in our documentation. We can see that, that's a required parameter that we've defined there. Very easy to understand how this API kind of works now. When we take a look at the responses, we have the 200 that we talked about. We've defined the schema of the object, the user object that's going to be coming back. And we've also gone ahead and dropped in some example values here. And this doesn't match our initial request, but this is just like a dummy account or something that we can spin up. The piece that I really want to point out is this 404. And the idea here, again, is that we have that 404 defined in a couple of different places. In this case, it's only 2, but that could be 10. It could be 100 different paths for this API, or it could be a 404 across our entire organization. Maybe that's something we want to standardize for every single API that we develop. When we look on the right-hand side, we can see that this is actually resolving to an object that we have defined somewhere else. And in this case, it's stored in a definition that's at the bottom of the file. So right off the bat, this is going to help us, again, define one instance of this response. And as opposed to us trying to maintain this across all these different paths and all these different requests that we need to support, we can essentially just create a reference here to the definition at the bottom of the page. And this is huge because, again, if we ever have any kind of request for this to be actually a string and we need to change this value, this is going to update, again, across the entire application. Makes it very, very easy for us to kind of change the way that this is going to resolve. And when we now hand this off to testing or we expose this to our consumers, they know exactly what to kind of expect. It's a string as opposed to an integer there. Let's just go ahead and change that back. Great. So I think, Dan, the last thing that we want to show here is going to be the mocking capabilities. Yeah.
Yep.
Okay. Sweet. So we've built this API, pretty straightforward. We obviously have some example values here, and I could start to kind of copy paste this, or expect my front end to support some of these different fields or something like that. But it's just values on the screen right now. What we want to do is actually make this a little more interactive, give people the ability to actually pull this data down themselves. Again, speaking to kind of facilitating that development and testing process at the same time. This is kind of a key component of that. So first, let's just save this. There we go. And
real quick question while we're in here.
Yeah.
From someone. Kieran, thank you. Could we have one schema refer to another schema?
That's an awesome question. Yeah. So if we had like a definition in here, like a 404, let's say, and we had a message value, and that message is actually defined somewhere else, like we're kind of nesting and nesting and nesting, we can absolutely do that. So this definitions can contain, let me think, responses, parameters, path ID or path items, and a couple other things. This is something that actually changed or kind of got fleshed out a little more with the 3.0 version of the spec. So there's a couple more things that are supported there. But one of the really cool things that we can actually do with Swagger Hub specifically is we can actually take this definition set and move it somewhere else entirely. So if we jump back, and get into this in a second, but if we jump back to say like this definition here, we can see that I've got here a reference to an external schema. So this is stored in something called a domain. It's essentially like a collection of reusable assets. We can think of it like a library of objects and responses, path items, parameters, stuff that we want to standardize and reuse across our entire organization. we can start to, again, create an external reference and kind of link back to that. We can resolve these. So, if I ever pull down the spec or I spit out code or something like that from this application, these will always get resolved. So it's not, tied always to Swagger Hub. But it's just a very nice way for us to, again, create a single source of truth outside of all of these different individual APIs for them all to look back to. And now if we say we want to change this book object, we could absolutely do that. Just jump into the domain into it. So great question, and ties in exactly with what we've been kind of talking about here.
Yeah, and Swagger Hub, another really quick question. On-prem, it's available on-prem installation or in the cloud?
Yeah, so we have two versions. We have the cloud version, which is what we're playing around with here today, and we'll be using from the Service V side. Essentially, this serves up a public API that we can pull all this data from. If we have our own, collection of APIs and we're at a certain scale, a number of teams that we want to support, then we can also deploy this on-prem. We support both like a, private cloud instance, if you want to call it that, as well as like sitting on a machine, on-premise, like
Physical
actually
infrastructure.
Right. So yeah, a couple of different options there when we start to talk about how we interact with this. But Swagger Hub, a number of different kind of options for getting in here. We do like free plans, we do team, enterprise size plans, and then we get into the on-prem stuff as well. Cool.
All right.
The mocking piece. So let's just show that off real quick. One of the nice things that Swagger Hub does is support a number of integrations. One of these is something called the API Auto Mock. Essentially what this does is it reads through and grabs all of those examples, responses, and all that data that we kind of fleshed out before, and essentially returns it through an API call. So let's go ahead and create and execute that. We should find now that our base path value has been updated. So let's just make sure that that's happened down at the bottom of the file here. Where did that go? And just try refreshing there. Essentially, yeah, what it's going to do, it's going to start to return some of those example values through like an API call. So it's pretty straightforward. It should be running here. Not entirely sure why it's not showing up. Let's just try a different one. That library one that we were talking about before should do it. Here we go. So now we see we have this little try it out now button that popped up. And this is letting us know that underneath this API, there is this like mock service running. Now we could link this to something different. So when we get into advanced mocking or service virtualization in just a second, we'll be able to show some of the more advanced functionality. But now when we execute this, we can see that we're actually running a curl command against the API, and it's actually responding with data, which is pretty cool. So we could go ahead, we could grab this. If I pull up my command line here, I should be able to now just drop that in. And just like before, we now start to get some data back. So this is cool. I can hit this obviously from my command line. This could be hit from like a front end application. So if I'm thinking, hey, I need to now support like a certain structure, my results come in this array of objects and I need to render those out in such and such a way. I actually have some data that I can make a call out to, and it's going to respond like the actual API will. The catch here is that it's always going to respond with the same thing. So no matter how many times I run this, it only has a single data set to read from. So if we did something like make a call for a specific book based on an ID, it's always going to give me back the same book, 101, 102, 103. There's only a single set of examples in here that are going to be returned back to me. And that is the problem that we're going to be able to solve with service virtualization here.
All right, awesome. You want to throw that back over to me?
Yes.
Yes, perfect. We will look at some of the differences between the two. Sorry about that. All right, should be back here. All right, that was awesome. So yeah, that's going to give you kind of that static mock response back.
Right.
And Service V is kind of the next evolution of that. So service virtualization is a method to fully emulate the behavior of a specific API or web service in your architecture to reduce system dependency. So Service V Pro, it's going to allow you to either emulate a live API. So we'll go through, well, we might not actually, but you can record live traffic and actually have that API's entire transaction history there to use. Import a Swagger definition, which we'll definitely do today, or we can just create kind of this RESTful API on our own. But it's a way to completely emulate the entire behavior and much more than just actually the response. So differences from mocking. It's hard to create hard to create a need scripting experience. You just saw kind of the built-in mocking in Swagger Hub, which is awesome. It gives you that stand up. This is already step one on that journey. It gets you out of just scripting that response. It gets you closer. You'll see where service virtualization is like step 5 on that. Often owned by other teams, lack of control. It's another huge thing. You're going to see how easy it is to share all these virtual assets within Service vPro. And then the next two are a little bit linked, but this is huge. Static and stateless. So static responses that are always going to give you back kind of that same piece of data, no matter what the logic is. And then stateless as well. Can't pass parameters from one response to each other. There's no sense of hierarchy there. It's just a very flat, static kind of response you're getting there. Service V kind of alleviates all of that and then does some other awesome things like the ability to configure performance, which we'll talk about as kind of the next level as well. So from a actual technical aspect, this is kind of the flow we'll be looking at is you have your OAS, let's say in Swagger Hub, you're designing and documenting that, and then you're importing it into the Service vPro tool, which will be able to stand that documentation up, that definition, and be live for your development team and for your testing team to use. And then these are the 3 main things we'll talk about today as far as virtualization, what they're going to bring to your team, both testing and development team. But it's going to give them the entire API whenever they need it. So you're going to be able to increase delivery velocity. We'll go through a normal testing cycle. You're also going to be able to improve application quality, just more edge cases, more end-to-end, more performance testing done earlier in the life cycle, and then a reduction of testing costs. Some of those third-party, some of those more expensive, resource-heavy endpoints are expensive to test. You're not going to do full-fledged performance testing on a Salesforce API that you're paying multiple cents per call. It's just a really crazy thing to do. So service virtualization is going to give you that really accurate kind of return on your responses that you'll be able to actually load test against that application.
And I think that second point there is really important and something, when I've spoken to a lot of people about this, they really hone in on. The idea that we can use a virtual service to essentially mock failures as well. It's not just that we're stubbing out like success or we're virtualizing like successful responses from an API. We can actually force like a failure scenario. So like when I'm building an integration against the API, inevitably it is going to not work at some point, right? It's like no application runs 100% all the time. So I need to be prepared for that. And I need to build out, the functionality to support when that happens. That can be really hard to do against like an actual API or production API. We don't want to, force it to fail at any point. That's probably the last thing that we ever want to do. So for us to be able to provide like this sandbox environment that says, okay, when I flip this switch, we want to have everything just turn red and we want to see how our application handles that. Something like a load test is a great example. That's really important. And again, it really kind of hardens what we do from a coding kind of perspective, and that influences like our quality down the line. Talking back to that kind of shift left mentality, when we can catch those bugs and resolve those issues earlier, it's gonna really pay dividends down the line and cut down on costs down the line.
Yeah, and sometimes it's not even like catching bugs, right? It's forcing your application into a state that's really not possible without service virtualization. One example we always give to our team here is, let's say you're on a train going into a tunnel and you just hit the send money on something. Let's say you just bought a new pair of AirPods and you were just going into that tunnel when you hit that button. So you hit the button and then all of a sudden you're 30 seconds in the tunnel and that circle just keeps spinning. It doesn't really give you a positive. It doesn't give you a negative. It just really doesn't know what to do. And that's because, quite frankly, for the development team to get that application into that state where I'm in this quasi mode is really, really difficult to do at the code layer. It's almost impossible, but you'll see that Service Virtualization and Service V Pro tool, we can really develop around those things because of how easy it is to get something like an API call into that state where, hey, I need to slow down my network connection over this next 30-second span. So maybe give me a little bit slower connection speed there. So it's huge.
Sounds like a real world scenario, Dan.
Yeah, right.
You've been ordering AirPods.
Yes, I'm getting very. It's my sister's birthday today, so I actually had to do that yesterday. All right, so let's talk a little bit about delivery velocity and increasing that. Here's kind of a visual example of typical test staging process across a 7 to 8 week journey. So in our first 2 to 4 weeks, always the bulk of the work, it's mostly spent on development. We have this 3 different components building this one application. And let's say each of these components are different OAS APIs. So we have 3 different RESTful APIs making this one application. And again, we're going to spend all this time in development. Let's say we get 2-3 weeks through, and then one of the components is fully done. So testing team says, great. That sounds awesome. I can actually start to get to work, but I can't do everything. I can maybe write some integration tests between some of these 2 components, but it's really difficult to do performance testing here maybe, or full end-to-end testing. So I got to wait. So the QA team is sitting there twiddling their thumbs while the development team is working on the spec. Then let's say we get through weeks 5, and now it's time to flip this on its head. So now all of a sudden, when the QA team is maybe not ready, they have 3 different components pushed at them because the dev team is all done. And now they only have 2 weeks till we go to production to run those end-to-end tests on, to run those user acceptance tests. All this, again, it really speaks to the complexity of getting a microservice, a service-oriented architecture application out the door and working with development teams, integration, testing, end-to-end testing to all give you that quality experience. And then finally, let's say this component B, that might be something that's third party. So even though all of your teams are done developing their own APIs, we actually can't ever get a good look at the full service because it's so reliant on that third party. We can't get a full look at production performance until we're actually in production. So this is a huge problem for the quality of your APIs and applications. But Service V and Service Virtualization really mitigates that. Here, let's say those 3 components had OAS definitions. We can virtualize that in weeks 1, in day 1. And we can start writing these integration tests, writing these end-to-end tests against the virtualized API without waiting for the rest of the development team to actually get done with their work. So then, as you saw in slides, couple slides up, our testing and development can happen at the same exact time. So instead of having development take 2 weeks, then throwing it over that wall and having, let's say, the functional testing crew write out some scripts against that and then be ready for production after weeks 3, that testing crew can start writing functional test scripts against that API before the development team has even started writing their first bit of code. Maybe they had something else to do on Monday and Tuesday. But all of those functional performance test scripts can be done before they even start. So this is a huge, huge time saver. Next, again, is that configuration, that ownership, the actually editing of all things APIs. So the performance, the responses, this gives us a complete ownership over, let's say, even a third-party API or an internal API that we might not be able to work with as and configure as closely. So here's an example. Let's say this payment processor, our CRM, our email system, payment processor and CRM are third-party. Let's say maybe this email we do ourselves. When we send a payment and that payment gets declined, that's something that is set up maybe in their sandbox on the payment processor side. Then it's going to come back and we're going to have to edit that information. So already we have 2 different calls that happen that we need to work with an API we don't control to get us in a state that we actually can work with. So already, next, when we actually save that new credit card information, we're going to save it to our own CRM. And that CRM is now going to have the new credit card information, which will then pass back to that payment processor to make sure if it works. So again, there's a lot of connections happening with a lot of APIs that we might not control, that we can't send dummy back on their side. But by virtualizing it, We control all of this. All this data is customizable. We can change the payment decline, whatever response they send back, we can edit on our own side. The credit card information, again, we're able to actually configure all of that information on the banking side, which isn't easy. A lot of banks a lot of payment processor, forward-thinking payment processors are decent about sandboxing. But even still, there's a lot of new ones. There's a lot of older banks that this will really give you that sandbox environment to allow you full control over that API. And then lastly is free ungated access to premium APIs. So this is where we're going to cut down on cost. We're really going to shrink our testing bill, but we're going to be able to virtualize these APIs and then use them before production, testing and development in live behavior, responses, all data, all of those things can be live. So we don't have to pay Google Maps. We don't have to pay expensive APIs. This one here, let's just say sports data coming back, a little expensive to actually get. We can take a free trial out for this. We can record all of our own traffic during the free trial. And then once that's over, we're going to still have our virtualized asset. We're still going to have those responses that we can develop against. And then once we go live and once we're ready to put this API in production, we can easily switch from our virtual API to the real API, and everything from the development side, from the functional testing side, performance testing side, should really work out of the box without having to change anything. And then lastly, just an example of it's not just on the API side, but a lot of this really helps out on the UI side here. So here's, let's say, a login example on the front end layer. We're logging into a tool, cross-browser testing. This login screen has multiple APIs behind it. All these APIs would have to be live, would have to be ready to run system tests against, end-to-end tests, performance tests against. By virtualizing all of these, we're able to run all of our tests earlier in the cycle. So we can virtualize that expensive security layer. We can virtualize that expensive email abuse engine we have and actually test and run through without incurring live costs on our actual production data. Again, huge cost savings when it comes to things like load testing. Throwing 100,000 fake virtual users at this login screen is going to result in not only angry managers, but also maybe some angry finance folks as they look at the bill for this, let's say, email abuse engine that all of a sudden 10x'd because it's November and we felt we had to make sure that our website was ready for the holidays. So huge, multiple layers of our application. And then really this helps out and it goes into testing. API testing is becoming more and more popular. 80% of testing today is done manually, about that 20% split between UI and API on the automation side. But the world is going to the automated testing world or space, and that space is mostly becoming part of the API testing paradigm. So we're shifting towards more than 50% of our testing, hopefully by 2020 or 2020, sorry about that, should be automated and at the API layer. So just huge growth in the API side, and virtualization is a big help with that. And just some reasons why that's becoming so popular. I think at SmartBear, we have a unique look at this paradigm shift because we have both sides of the house. We have so much UI testing, so much API testing knowledge, but there are some inherent pros and advantages of API testing. First being the immediate testing of business logic. We can test faster in our sprint. We can test earlier. We don't have to wait for the full application. Service virtualization even doubles down on that. Less brittle and easier to maintain. If anyone's ever worked with Selenium or any testing on the front end, you know that everything is always changing, either from our own designers, our own developers, or on the browser side. So tests are failing left and right. API tests are much more resilient, and they're easier to maintain over time. Next is faster test execution. So again, coming from the UI side, a test might take 2 minutes, 3 minutes. That end-to-end, filling out that whole form, spinning up the browser, tearing it down, that all takes a long time. API testing is much faster. We should be able to run through API tests in 1, 2, 3 seconds, make sure we get those calls back. And then lastly, I think this really becomes evident when we look at some of those end-to-end graphics, but faster root cause analysis. This is huge on the functional performance side. When you test that UI, there's 50, 100 different services that could have caused an error, and you're not going to get that immediate root cause. On the API side, when something fails, we can really closely track what failed, where it failed, and hopefully get a fix in production quickly. All right, so with that, I'm going to turn it back to Nathan, and we are going to fire up a spec in Service V Pro and really edit it and show the power of virtualization over mocking.
Yeah. Awesome. So while Dan was running through the slides there, I was able to resolve the issue that we were having with the auto mock on the HR API. So we'll be able to plug away with this. But again, it just so to kind of double down here, obviously I submit a user ID here, we get a call back, it's going to match, but if I update this, the data is still going to be the same. And that's, again, something that we're really going to hone in on and kind of, show an example of here in Service V. So let's go ahead and open up Ready API. Now, Ready API is a collection of different tools. It's going to have our functional testing. It's going to do load testing. It's going to obviously do service virtualization, which we'll talk about today. Key thing here is that we can reuse a lot of the assets. So if I generate a functional test or I import a service definition and I generate a bunch of tests off the back of that, I can use that data in load UI, Service V, et cetera. So a lot of reuse, a lot of kind of updating from one piece to the next. There's a really nice structure to this that makes it very easy to kind of scale up with the platform. For our use case, let's go ahead and create a new empty project. Now we do have an integration that we support with Swagger Hub. So let's go ahead and import from Swagger Hub here. We can also do this manually. So if I want to just bring this in from my local machine, or I just wanted to, make an API call or something to some kind of repository service, then we can start to do that as well. Now let's go ahead and see if we can remember the name of the API that we developed. There it is. So we can see that we've got a couple of versions that we could pull down. Someone asked a great question. I hope I have time to answer it about like if we get a new version, can we kind of pull down those changes and bring them into Service V dynamically? It's an awesome question, something that absolutely we can do. But for now, let's just go ahead and bring that version 1.0 in. We'll see essentially it's going to bring that into the application. It's going to create this little tree structure on the left-hand side that really just breaks down the spec into its paths, methods, and then finally the individual requests that we define. Now, all we have to do to bring this over into the virtualization space is just right-click on that service definition and generate a vert. We'll have some options to pick and choose if we had a bunch of different paths, or maybe we want to run this on a new port. We can start to configure this here, but we'll find that as soon as I hit OK, we're brought over into this virtualization tool, and all of the data now from that specification has been converted into this virtual service. So we could just set this running, and essentially I could start to make some calls against localhost 8085, get some data back. Now, when we look at the tool here, there's a couple of different columns that I want to walk through. On the left-hand side is the requests that we're listening for, right? This is running, it's serving up data. These are the requests that we're going to be listening for. Anything outside of this return is like a 500 or something like that. On the right-hand side are our responses. And we can see that when we select the first one here, or maybe the second one, all of the data from the specification can be just dropped right in here. So we've got this little editor. It should have happened dynamically. I'm not sure why that didn't work. But let's say that we want to grab like the response that we were working with previously. Let's just go ahead and now we can drop that right in there. Now when we look at the response 2, obviously this is where we'd want to drop off 404. We can see that it's already recognized that we had that defined. So we'll just go ahead and grab that 404 message. And there's probably something that I dropped in here that caused this not to import directly, but typically it brings over all my example values into the tool here. Now, we've now got these two responses defined, my 200 and my 404, and it's the center column that is really going to separate us from that auto mock feature that we were talking about before. When we look at the dropdown here, we've got a number of different pieces of logic that we can drop in. that tell us exactly how we want to serve up one of these two responses. So we could do this in a sequence, essentially just flip a switch between these two. We could grab them at random. We could match to a specific kind of value in the like a post body or something like that. That's what these next few options are. For us, let's go ahead and grab this parameter option. We know that we're going to be getting, that UUID parameter coming in. So we want to make sure that we kind of match that to maybe a specific value, and then we return a particular response based off that. So if we say our UUID parameter should be equal to, let's make sure we grab the same value here. Just jump back in. If it's equal to this, then we'll send back response 1, which was the 200. Anything else, let's return that 400. And now if we make a call out to localhost 8085 with the value that we're expecting, we should see that it returns the data in the way that I expect. So let's just go ahead and do that. Again, we could do this from outside of the application, but just because we're working in here, we'll just use the tool. Let's go ahead and run our request. We can see that we're getting a response back. And now let's go ahead and try and update this information. And we can see we're getting back this 404. So right there, we separated ourselves from that auto mock. It's starting to respond like the service actually would, right? We're looking for particular values. But someone out there might be saying, well, that's great, Nathan, but we're only serving up one piece of data, right? Now, one of the cool things here is that we can actually start to build on top of this. So let's say that I have a good response here, and it can go ahead and clone this down. And we could go and drop in some new information here. Maybe it's me who's going to be added to the HR database. All we'd have to do is, again, just add a new rule that says, hey, when we're looking for that ID that I think was equal to 33, let's go ahead and return that copy of response 1. Hopefully we'd enforce some good naming conventions here so we are not kind of digging through these. But when we look now, we could see that this same call should return back, should have returned back the Nathan Wright one. I might have updated the wrong information. There we go. Okay. So 32 should be me, and 33 should be James here. Perfect. So now we can start to kind of plan out and get an idea of these different values that are be coming back. It's kind of onerous though, right? It's like if every different response that I want to support, I have to go in here and start to update manually. That's a real hassle to do, and I don't necessarily want to do that. So what we can actually do is start to replace some of this information with dynamic data. Now, the idea here being that maybe we have a data sheet, maybe we have a database that we're pulling information from, maybe we have a very specific set of user IDs that we want to kind of iterate through, or maybe one of these is going to be a failing scenario that we want to spatter in there at random. When we look at this last tab in the service fee screen, we can create something called a data source, and these come in a bunch of different flavors. So we can connect this to an external Excel sheet. We could connect it to a database. In our case, let's just go ahead and use this data generator option, and maybe we'll just call this first name. I think we have a first name generator. And when we navigate through here, say name, do first name, and now when we jump back into the setup and we open up the same response, essentially all we'd have to do is start to connect to that data source that we just defined. So we can only do this once per response, but we could create a whole stack of different properties underneath this data source. So there's a lot of data that we could start to serve up. But now from this menu, we create a reference to the property that we just defined. We've created this little reference here. This is something that we call property expansion, where we're essentially going to evaluate this to a value that's outside of this editor. And when we see this in action, let's just make sure that we're getting the right ID. We'll find that that first name should now be updating with every new call. So this is pretty cool, right? Now we've got something a little more dynamic. We can't just hard code our front end to support a certain length of name or something. Maybe we have a very long name that gets thrown in there at random, and we have to make sure that we're supporting that. Or maybe we get a bad user ID coming back for some reason, an empty email address. All this data we can start to store in that external source. We could have an individual response that's just iterating over that entire set and returning that data to the client. So really just, looking at taking it a step further than just that mocking or that stubbing functionality. It's responding like a service. It's got a little bit of logic layered in here. It's got some kind of dynamic properties, so it's always changing. This is huge if we have something like a date time stamp. We can actually start to serve that back for the relevant time as opposed to it just being something that's hard-coded. So there's a lot of capabilities here that we can start to leverage. One other thing that Dan mentioned was the ability for us to mimic like slow response times or something like that. In the behavior tab of this tool, it's very easy for us to just drop in something like a very specific latency. So if we want to say, this is actually going to take a second to respond every time we make a call out. Again, nothing that I really have to do to update this. We'll find that now we're hitting a response time of about 1,011 milliseconds. That should be pretty consistent. So a really nice way, again, for us to make this look like an actual service as opposed to just something that responds immediately or is running in the background on my local machine. This actually kind of responds like a true service would. Great. Was there anything else before we start to get into some questions and stuff, Dan, that you wanted to go through here?
I don't think so. We have some questions. Also, I guess one thing real quick, you want to just import a Swagger spec?
Yeah, we want to see that.
Yeah, exactly. Let's see a full one go through.
Yeah, let's grab that library one because that seemed to play nicely for us.
While we're doing that, I'm going to throw up a poll right now. It'll only take a little bit. Are you interested in learning more about how SmartBear API tools can work for your team? We have 4 options there. Please just vote, and then we'll start the Q&A after that. We'll also import this. Good segue for Nathan.
Cool. All right, so let's just go ahead here and bring down that spec. So again, I think the fact that we can do this is
all right, don't do anything yet. Right. Screen.
Just remove that.
All right, 5 more seconds. 3, 2. All right. Awesome. Back to the job.
Cool. So what we're going to do here, we're going to make a call directly against the API. So maybe there was something that wasn't getting resolved properly when we imported that before. But when we do this directly, and just like before, we generate that virtual service. This one's a little more interesting. We've got some different responses, some different paths. Just go ahead and stand that up. When we open up some of these, we should find that we actually have the example data. So this one imported correctly. It's got those examples that we took the time to spin up. We could, jump in here and start to plug in some data sources for generating IDs between 0 and 1,000 or whatever it might be. So yeah, it's done a really nice job of kind of resolving this, and now all I'd essentially have to do is start to create the logic in the center here. So that's pretty neat. Now, one question that I do want to answer before we get any further is the ability to update these virtual services. So let's say that we've been using 1.0 of this Swagger specification, and now 1.1 is available. When we right-click here, we have this ability to update a definition. We can update the path or the location of the Swagger spec that we're going to be importing. And we see that we have the ability here right in the center to add these new methods to virtual services. So what this isn't going to do, it's not going to like refactor all of the work that we've previously done. We do have a setting for that, but it's something that's a little more involved, and we essentially have to map like new data, old data. What this is going to do, it's going to read through all of the old specification, map it or match it up against the new one, and pull in any new methods or definitions that didn't exist before. So as we build that new functionality, as opposed to us starting from scratch, we can just continue to pull those definitions into the tool and start to layer that into this already running service. So we're going to be able to leverage the the time that we put into building out the logic and connecting to data sources, and essentially just like update that with new information as it's available from our design or architecture team. So hopefully that answers the question that somebody kind of asked earlier.
Awesome, thank you.
Yep.
All right, this one's kind of two-parter, and I'm throwing them together. There's one huge thing we actually kind of missed, but definitely no one let us forget with the questions. Profiles, environments. Let's go through how we can have a virtual asset, change things out on the environment really quickly, and be able to test against a couple different scenarios without actually having to create a whole new vert.
Do I have time to do this against a third party? Is what I'm
You
wondering.
might not.
Okay. In that case, let's we'll just jump back here. Yes, we support environments within the application. Let's say that we have this virtual service running. We have a production or a UAT level service. We can define those as what we call different environments. So here we have that vert. We can see that our services are tied to the local machines, and then we could have maybe those UATs, and maybe that's running on the network. So we could just go ahead and update that to some other IP address, whatever that might be. Now, when we jump back into the kind of query side of things, the client side, and we look at one of these calls, here we go. We have the ability up at the top from this dropdown to essentially say, okay, let's work in our virtual environment. Our endpoints are locked in based on what we stored in that environments manager. Okay, now we're going to run this against UAT. That is updated across the entire project. So not just at this like projects level where we're just running simple queries and getting response data back. If we had like test suites and test cases and we had like a ton of data underneath our kind of testing component, then we can start to manage this again through these different environments. So pointing these tests to different locations. And this is also something that we can invoke through the command line.
That was going to be my second part.
Yep.
So second part of this question is, can this all be done in a CI/CD fashion? And it certainly can, either command line or we have native integration with Jenkins. But you can throw up automatically any of these virtual assets, even from an environment standpoint. So let's say fire that first QA virtual asset, put it up, fire it up so I can test against it, then tear it down. And then in my next part of my CI pipeline, I might actually fire up my UAT environment. So I can have multiple different environments on that virtual asset getting started and stopped.
Right. And one other thing that I should mention, these are all running locally right now. So the only person like Dan sitting right next to me, he can't hit these services, which is okay because I own these right now and that's fine for me. But if I do want to start to share these, we can absolutely start to deploy them to shared environments through something called the Vert server. This is a component that like sits in the middle of our larger organization. Maybe it's a team, maybe it's a kind of a business unit, maybe it's our entire org. We have this essentially bucket of virtual services that we can start to upload from my local machine to the central service. And then essentially anyone in the org is going to be able to make a query against this. As long as they know the path or the endpoint that that's running on, they know the port that we're hosting a particular service on. We could have a ton of these running in parallel. We could have calls coming in from a bunch of different locations. We could be running load tests against them or stubbing out third parties as opposed to running it against a kind of an actual service like the Salesforce example earlier. By hosting these in this Vert server component, we really can start to leverage this at an organization level as opposed to being this kind of neat thing that I can do locally.
All right. We might get kicked off here, Nathan,
Yep.
in 20 seconds. But thank you so much for the presentation. Any unanswered questions, we'll try to get back one-on-one. You can find a free trial of this, smartbear.com. Go check out Service V Pro. It's in the Ready API suite. We have a total free trial available. And same thing for Swagger Hub. So if you're using that Swagger spec, check out swagger.io, and you'll be able to get a free trial and access to the cloud solution at Swagger Hub. Thank you so much, everyone, for your time. And Nathan, again, thanks for the presentation.